Okay, so in section 4.2, we're going to be talking about linear models. And what we want to do is be able to take the information we know about linear functions and apply it to real-world situations. So in a lot of situations, it is a linear model. Not all situations are linear models. Okay, so the linear function can be written as f of x equals mx plus b, where m is the slope and b is the y-intercept. And we know that they graph to be functions, transformations of the identity function, except for the constant function, which is linear. Okay. Now, a lot of times in our situations, we may not be dealing with negative x values or negative y values, so I'll just say that. All right, so let's look at this situation. Example 4.2. A town's population has been growing linearly. In 2004, the population was 6,200. By 2009, 5 years later, the population was 8,100. So the way we're going to set this up, I'm going to do a little graph here, and we're going to say this is 0. Year 0 is going to be 2004. And so if I count by 2,000, 2, 4, 6, 8. Okay, so let's say this is 2,000. Then in that initial year, I'm going to say 0, 2004, that's our earliest data. The population is just over 6,000, so 2, 4, 6, so like right there. Now, you may be saying, well, I don't want to do it that way, but this will greatly help us to have the origin as part of our graph. Okay, so then we're going to count 5 years later to 2009. So this is how many years we're going in the future. And then we could go, this is after 2004, and then we could go 10 years after that. That would be 2014, right? Okay. In 2009, see, and this might be hard to understand, this is 2009, 5 years after 2004. So I'll just put that there so you can see it. And then this would be 2014. Okay, in 2009, or 5 years later than 2004, the population was 8,100, so just over 8,000. So we see this trend going like that. You can see it's a linear function and that it has a slope to it, a slight slope to it. So what we want to do is we want to be able to calculate the slope based on these ordered pairs. The ordered pairs I have are 0, 6,200, and the other ordered pair is 5, 8,100. So I'm going to put those in the slope formula and calculate the slope. 8,100 minus 6,200 over 5 minus 0, which turns out to be, I think, 1,900 over 5, which turns out to be 380. Okay, you can use a calculator for all that. Okay, so I know the slope. Now I want to come up with the equation. Well, I don't even have to use the point slope formula because I already know the y-intercept. The y-intercept was right here. That was one of the advantages of putting that initial data right at the origin. So I know b is 6,200. So that's coming from there. So my equation is going to be f of x equals mx plus b. Well, my slope is 380, and my y-intercept is 6,200. Okay, now I have a model that I can use. So when they ask me to, one thing you have to remember about the model, x is the number of years past or after 2004. Y is just the population. Or I should say f of x. Okay. So they want us to predict the population, f of x, in the year 2013. Okay, so how many years after 04 is that? 9 years? Okay, so I'm trying to find f of 9. Now, where did that 9 come from? So it was 2013 2013 minus 2000, okay, that just looks messy. It's 2013 minus 2004. So 9 years after 2004, because that's where our graph started, that's what we're evaluating it at. That's what we're going to put in for x. So 380 times 9 plus the 6,200. Okay, so we'll do this real quick. 380 times 9 plus 6,200. And I get 9,620. Okay, so that's the population we're predicting. 2013. So if the linear model holds, we're expecting the population to be about 9,620. Okay, the other question here is a little bit different. It says identify the year in which the population will reach 15,000. So they're giving us the population, the f of x or the y, and we're trying to figure out the year, which is x. Okay, identify the year. Okay, we use the same model. So f of x equals 380x plus 6,200. But we know the population, the output this time. So we're going to have to subtract the 6,200. What's 15,000 minus 6,200? 15,000 minus 6,200. 8,800. Whoops. And that's going to equal the 380x. So divide by 380. And what do we get? About 20. Well, I wrote that goofy, didn't I? Okay, x is about 23 years. 23 years after 2004. So in the year 2027, we're expecting the population to be about 15,000. And then we can say, okay, well, by the year 2027, we're going to need so many hospitals, so many schools, and that type of thing. Okay, does everybody know where we got the 2027? It's 23 years after 2004. Okay, so that's how real models work. The good news is there aren't a lot of examples in this section, but they do take a while to do.